Hi, myself Vijesh. I'm from Trinity College of Engineering. Now we are going to discuss about electric charges. We can see two kind of charges in the universe. One is positively charged and another one is negative charge. If an atom loses its electrons, it will become positively charged. At the same time, if it gains an electron, it will become negatively charged. Now, if we place a charge of value q1 here, there will be a electric field around it. If you place another charge of value q2, there will be also a electric field around it. Now we are going to place both these charges together with a distance of value r. Then there will be a force between these charges. That force is explained by Coulomb's law. Coulomb's law states that if you place a charge q1 here and another charge q2 here, and the distance between both these charges is r, then the force experienced between these charges is F, proportional to the product of both these charges, that is q1 and q2, and inversely proportional to the square of the distance between these two charges, that is r square. That is the Coulomb's law. Here F proportional to q1 q2 divided by r square. Then we need to change the proportionality. Then we can use the proportionality constant 1 by 4 pi epsilon, that is F equal to q1 q2 divided by r square. The proportionality constant is 1 by 4 pi epsilon. Here epsilon is the permittivity of the medium or dielectric constant. Epsilon can be denoted as epsilon 0 into epsilon r. This is the Coulomb's law of force equation. Now we can go for a problem. The first problem is a charge of value q2 is equal to 121 into 10 raised to minus 9 coulomb is located in vacuum at point minus 0.03, 0.01, minus 0.04. It's the coordinates, and that point is on space. Find the force on q2 due to another charge q1 of value 100 microcoulomb at a position p1, 0.03, 0.08, 0.02. That is, all distances are in meter. Okay, that is, here is the x-axis, this is y-axis, z-axis. There is a charge q2 with a coordinate p2, and another charge is placed at a point 0.03, 0.08, 0.02. Then this is the second charge q2, this is the first charge q1. Then we need to find out the force experienced between these charges. First we need to find the distance between these charges. We can denote the distance between these charges as d or smaller. First, in order to find out the force between these two charges, we need Coulomb's law of force equation, that is F equal to q1 q2 divided by 4 pi epsilon 0 d square. Since it is in the vacuum, the epsilon r is 1. That's why epsilon can be denoted as epsilon 0. In the question, the q1 are given. q1 is equal to 100 microcoulomb. We can convert it into coulomb, that is 100 into 10 raised to minus 6. Then q2 is 121 into 10 raised to minus 9 coulomb. That is here. Then 4 pi is 3.14. Then we need to substitute the value of epsilon 0, that is 8.854 into 10 raised to minus 12. Here we need to find out the distance between these charges. Since the coordinates of two charges are given in the question, we can find out the distance between these charges easily by using the equation d equal to first x1 minus x2 the whole square, that is x1 here, x2 here, x1 minus x2 the whole square, then y1 minus y2 the whole square plus z1 minus z2 the whole square. We can use this equation. Then we can find out the value of t, that is 0.11 meter. If you apply this value directly to this equation, we can find out the force, that is F equal to 8.989 newtons. That is the force on Q2 due to Q1 is 8.989 newton. Okay, then the next problem is here 2.6. Here 3 concentrated charge of 0.25 microcoulomb are located at the vertices of a equilateral triangle of 10 centimeter side. Then find the magnitude and direction of the force on charge due to the other two charges. That is, there is a equilateral triangle here. Since it is an equilateral triangle, then the angles are 60 degree, 60, 60, 60. Okay, then here there is a charge q3 and here there is a charge q1, here there is a charge q2. Now we are going to consider q3 is a reference charge. Now we have to find out the force experienced by q1 to q3 and the force experienced by q2 to q3. That is, here the first force, here the second force. The total force experienced on the charge q1 is the resultant of both these charges, that is F. Okay, first we need to find out the total force. Before that, we need to find out the individual force experienced by all charges. First, we need to find out the charge experienced by q1 to q3. That is, we can denote it as F13. Here the first charge is q1, second charge is q3. By using the Coulomb's law of force equation, F13 equal to first charge into second charge, q1 into q3 divided by 4 pi epsilon 0 r square. q1 is 0.25 square. Okay, here the unit is in microcoulomb. That's why we can use 0.25 into 10 raised to minus 6, and q3 is also 0.25, that is 0.25 into 10 raised to minus 6. Okay, q1 q3 divided by 4 pi. The value of epsilon 0 is 1 by 36 pi into 10 raised to 9 into the distance between these charges is given in the question, that is 10 centimeter. 10 centimeter equal to 10 into 10 raised to minus 2 meter, that is 0.1 meter. That's why r is 0.1. We can find out the value of force is 0.05625 newton. Similarly, we can find out the value of force experienced by q2 to q3 using the equation F23 equal to q2 q3 divided by 4 pi epsilon 0 r square. The value of q2 and q3 are also given in the question, and we can find out the force by using this equation. The force is equal to 0.05625. Then we need to find the total force experienced by both these charges. That's why we need to consider the equilateral triangular. Once again, is a charge q1. The force experienced to the charge q3 is in this direction, and the force experienced by q2 is in this direction. This is F1, this is F2, that is F13 and F23. The resultant force is here F. Since it is an equilateral triangular, this angle is 60 degree, also this angle is 60 degree. That's why the opposite angle, this is also 60 degree. Since it is a resultant, this is 30 degree and this is 30 degree. Okay, then we can use this equation. The first component is f13. Okay, f13, the angle is 30 degree. That's why the vertical component is f13 cos 30, plus the second force is here, and it is f23 into cos 30. The total force can be found out using this equation, and the total force is 0.09743. Thank you.